Yes, ma'am. Yes, ma'am.
Okay, okay, fine. This is what I really want to show you because only if you know what is a network and how it works, then we can move on to that session. So if you see here, this is a single neuron. Okay. So this is a simple neuron. So before getting into that coding, let me explain you what is a neuron and then how is a neural network model will be. So as I said, it's a simple neuron without bias. So we don't use for the first one for most of the time, and then we'll go for the second one. Okay. So if you see that second one here, this is actually a simple neural network. So here we have this is actually this dot represents your input, and this is your hidden layer, and this is your output layer, and it generates an output A. And A is nothing but it's a function over of a WP plus B, where W is your weights and P is your input and B is a bias. So and here what is actually happening here is your the input. So sepal length and width, that is the example, the previous example let us consider. So here the features are nothing but you are taking sepal width and length. So each will be given some weight. Okay, so weight is nothing but here the weight is going to play a major role here in this neural networks, because it is going to train the network and then it will make the network such a way that it will make of optimized classification. So here initially you'll be assuming some random weights, and accordingly the weights will be updated. And again we have some learning algorithm for updating that weights. And with this, what happens here is actually it's a mathematical operation here. So for the weights are being multiplied with the inputs and it is added with the bias, and it is given to a what say activation function f of. So something is going to happen over this WP plus B, and accordingly you will be getting the output A. So this is how a simple neural network looks like. And if you see here the different transfer functions, as I said, it's some function is being some process is being taken over here for this input and the bias. So